Okay, here we start with page 3. We're going to write the solutions for 7 through 14 of these compound inequalities. So we start with number 7. We've already been given the answer here, so x is greater than or equal to 7, or x is less than 3. And we put these little braces on it and write the x such that, and we get this. So that's the solution. The graph. Compound inequalities, I like to use a couple of different colors, so we'll use blue for this guy. So here's 7, and we have greater than or equal to 7, so we use a bracket because we can equal 7. And then 3 is here. Guess we should put a 0 on there, shouldn't we? So we know where everything is. There's 0, there's 3, there's 7. And the 3, it says x is less than 3, so it's going to look like that. Color all these numbers down here. And there's nothing special, we're just having the answers are either bigger than or equal to 7, so all those numbers will work, or less than 3, all those numbers will work. Now we need to write it in interval notation. So we have from negative infinity up to 3, and this symbol for or is the union symbol, U, 7 on up to infinity. Oh, but this 7 isn't a parentheses, it's a bracket, square bracket just like we used there. Number 8. Here we have something we really need to solve. So 2x plus 5 is greater than or equal to 7. If we subtract 5 from both sides, we get 2x is greater than or equal to 2. X is greater than or equal to 1. And we have the other one. 4x minus 3 is less than or equal to 15. It gives us 4x is less than or equal to 18. Divide by 4 and we get x is less than or equal to 18 fourths, which is the same as 9 halves. So here we could write the solution as that and that, but as we look at the graph, I think we'll see a little bit easier way to write it. So here we have a 0, there's 1, and there's 9 halves. So if we do this color thing again, where we've got blue here, greater than or equal to 1, I'm going to mark it up here. That looks like this. All of those numbers are greater than or equal to 1. And if we have this guy in red, now everybody knows that blue and red make purple. So if we look, it's these numbers right here from 1 that were colored red and blue all the way up to 9 halves that give us, these are the numbers that are red and blue. So that gives us a way of writing our answer as set of all x such that x is greater than or equal to 1 and less than or equal to 9 halves at the same time. And that gives us, this is a compound inequality that we can write in this way. Interval notation, we write the 1 and the 9 halves. It's going to be the interval from there, and it's going to be a bracket here and a bracket there. Number 9. We have 3x minus 2 is less than or equal to 1, so that's 3x is less than or equal to 3. X is less than or equal to 1. Or 5x is greater than 25. That's x is bigger than 5. So we draw our little, and there's 0, there's 1, there's 5. This guy be here, and it's right there, and then this other one, and here we have an opened all the way up that way. So interval notation looks like this, from negative infinity to 1, closed on 1, open on negative infinity, union, meaning the or symbol, and going from 5. Notice we don't include 5 as the answer, just like the symbol here on the graph, up to infinity. And writing that as set notation, we have the set of all x such that, well, we can just write it that way. X is less than or equal to 1, or x is greater than 5. There we go. Number 10. If we add 5, are you done? What'd you get? They'll put you in pre-calculus right now, right? 1050 or 1060. Okay, let me know if you want to come in again. Just give me a call. You betcha. Number 10, we get 3x plus 5 is greater than negative 7. That's 3x is greater than negative 12. So x is greater than negative 4. And 2x is less than or equal to, if we add 3 here and add 3 here, we get an 18. So x is less than or equal to 9. So if we look at this on the graph, there's 0, there's negative 4, and there's 9 way up there. Do our little color coding thing here, blue. So if this is an open, and it heads this direction, and then the red one right here has a closed on the 9. It heads down this way. So our end result, red and blue together, make purple. And we have not including 4 and do include 9. And write our answer in interval notation. So there's the graph of the solution. Our answer is from negative 4 to 9. And set notation, set of all x such that x is greater than negative 4 and less than or equal to 9 at the same time. Number 11. 4 is greater than negative 3 minus 7x. Add 3 to both sides and we get 7 greater than negative 7x. Divide by negative 7 and we get x bigger than negative 1. Remember to switch the sign if you ever divide by a negative number. Or add 4x to both sides and we get 6x greater than or equal to 24. Divide by 6 and we get x greater than or equal to 4. So a little number line here. There's 0, there's negative 1, there's 4. So there's this guy, x less than negative 1, so we're going to go open, down forever, and from 4 up, but that's closed, that means we hit it all the way up. So writing it out in interval notation, we get negative infinity to negative 1 union 4 up to infinity. Number 12. We subtract 3, we get negative 2x greater than or equal to 14. That's x less than or equal to negative 7. And right here, if we subtract 4, we get negative 5x greater than 5. So if we divide by negative 5, that's x is less than, again, switching the sign for a negative number, negative 1. So as we do these two, it's going to be very interesting to see how this one comes out. Here we have 0, there's a negative 1, and there's a negative 7. Let's mark this guy in blue. Less than or equal to a negative 7 is like that. And less than negative 1 looks like this. So if we look at this and here, we're looking for the red and the blue that make purple. And we notice that only the blue guys, all of the blue guys here are colored in blue and red. So our end result for an answer are all of these numbers. How do we write that down? Interval notation, that's negative infinity up to negative 7. closed there, open there. And set notation says set of all x such that x is less than or equal to -7. Now at this point you may wonder, wait, it's like we threw that guy away, and that's true. We're saying we want all the numbers that are both less than -7 and less than -1 at the same time. And anytime you have a number that's less than -7, it's definitely less than -1. But numbers like -2, -3, -5, they may be less than -1, but they're not less than or equal to -7, so they don't meet the condition of and. So that's why this is the one that turns out to be important, and that one turns out to be, in this example, irrelevant. Number 13. 12 is less than -3 plus 3x. So we add 3 over here, and we get 15 is less than 3x. And divide by 3, and we get 5 is smaller than x. Or subtract 4x over here, and we get -2x is greater than or equal to 6. Divide by -2, and we get x is less than or equal to -3. So as we look at these, there's 0, here's 5, and here's a -3 in blue like this, and it goes all the way down there. We'll put x greater than or equal to, less than or equal to -3 like this, right there. Now, in this one, we're looking at the word or. Unlike what we did up here with the and, we're not looking for what's red and blue at the same time. So we're not looking for the purple ones down here. We're looking for any numbers that have been colored red or blue. Certainly these have been colored, both of them, but all of these blue ones up here count in our solution, as do all of these guys. So our in solution turns out to be just written as one inequality. As we write that as a set notation, set of all x, such that x is simply less than 5. You're like, well, is that irrelevant? Well, sort of. If you have numbers up here, in order to be true, a solution of this inequality, this compound inequality, the or means you only really have to be on one of them. And it kind of makes sense. So this is what our answer looks like, and the interval notation looks like this, and the red one kind of becomes irrelevant in this problem set. And number 14. 2x, subtract 5 from both sides, is greater than or equal to 2. That's x is greater than or equal to 1. And x is less than or equal to 15. Oh, that's nice. They gave us the answer right there. So we have 0, 1, and 15. There's x greater than or equal to 1, and x less than or equal to 15. So our in solution, red and blue make purple. So we have in interval notation 1 up to 15 closed on both sides, and then x is less than or equal to 15, less than or equal to 1, and a cute little x with some braces around it, and that does it.